Welcome to The Explainer. Today we are diving deep into a really critical vulnerability that sent some serious shockwaves through the web development community. It's called React2Shell. We're going to break down exactly how it works, why it is so incredibly dangerous, and most importantly, what you need to do to make sure you're safe.
So let's just start with what makes this thing so scary. This isn't your average bug. We're talking about a super stealthy, really powerful exploit that can completely take over a server. And get this. It does it with just one single, carefully crafted message that just sails right past most of your standard security tools.
All right, to really understand how the heist works, we first have to understand the vault they're breaking into. And this isn't just about any old web tech. This is about a whole new way of building apps called React Server Components, or RSCs for short. And believe me, they change the game.
So, unlike the components you're used to, which run in your browser, RSCs live and breathe exclusively on the server. And that means they have the keys to the kingdom. We're talking direct access to databases, the file system, even your environment variables and secret keys. All the stuff you'd normally lock down tight.
Now here's where it gets really interesting. It's how these things talk to each other. See, instead of sending a bunch of JavaScript code over the wire, the server sends a set of instructions, a sort of blueprint, or what's called a serialized model. This blueprint tells the browser exactly what the UI should look like and how to build it.
So how does an attacker actually break in? Well, the vulnerability isn't really in the server components themselves. The real weakness, the backdoor, is in that communication process. It's a fundamental flaw in how the server trusts the blueprints it receives.
And that process has a name, deserialization. A great way to think about it is like getting a piece of flat pack furniture. The server receives a box of data, the flat parts, and its job is to unpack it and assemble it into a useful object in its memory.
Okay, so here is the absolute crucial point. The whole system was designed on a huge assumption of trust. It just assumed that any data it received was safe because it was coming from its own React client. And that broken trust is exactly what React2Shell exploits. It sends this malicious package, a Trojan horse, that the server just happily unpacks, not realizing it's literally building its own doom.
All right, let's get into the nitty-gritty. How does an attacker actually turn a simple data package into a weapon? Well, it's a really clever, multi-step heist that abuses the fundamental rules of JavaScript and twists React's own internal logic against itself.
So the attacker's ultimate goal, their holy grail, is to get their hands on this super powerful but also incredibly dangerous tool that's built right into JavaScript, the function constructor. This thing can turn any string of text into code that actually runs. You can see why it's normally kept under lock and key.
And this just brilliantly lays out the attack chain. It's amazing, really. The attacker doesn't kick down the front door. Nope. They just send a very confusing set of instructions that tricks the server into using its own tools, its own keys, to run their malicious commands. That's what makes this thing almost invisible to traditional security.
So let's zoom out and look at the bigger picture. Why did this vulnerability, which is officially tracked as CVE 2025-55182, cause such a massive panic in the developer community? Well, the potential impact is just huge.
Yeah, we're not talking about some small niche library here. We're talking about millions of applications built with modern React and Next.js. Think about it. Massive enterprise platforms, huge e-commerce sites, even government services. All of them were potentially wide open.
And this isn't just some minor bug. This is a critical, potentially business-ending flaw. Why? Because it's incredibly easy to pull off. It bypasses the very security systems meant to stop these kinds of attacks, and a successful exploit doesn't just steal a little data, it gives the attacker the keys to the entire server. Game over.
Okay, so take a good look at this table. These are the specific versions of the software that are affected. If your application is running any of these versions of React or Next.js, you are at a very high risk and you absolutely need to take action.
So, after all that, what is the most important thing you need to take away from this? How do you lock down your environment and make sure your applications are protected, like right now?
I really cannot stress this enough. The first, the most critical, the non-negotiable step is to apply the official patches. The React and Next.js teams have released them. Do not wait on this. Do it now.
And here are the versions you need to get to. This is your safe harbor. You've got to upgrade to React 19.2.1 or later, and if you're using Next.js, you need to be on version 16.0.7 or later.
But hold on, patching isn't quite enough. You have to work under the assumption that your credentials might have already been stolen.
That means you need to rotate all of your secrets, API keys, database passwords, the whole shebang. Then, harden your firewalls with new rules to spot these attack patterns, and actively hunt through your logs for any signs that you were already hit.
You know, when you take a step back, React2Shell is a really powerful reminder. Even as we build these incredibly sophisticated, powerful web architectures, the classic, old-school vulnerabilities like unsafe deserialization can come roaring back in new and dangerous forms. It really leaves us with a critical question we have to ask ourselves. As we innovate faster and faster, are we paying enough attention to the absolute foundations of security?